So the word percent means per hundred, and it is related to ratios. And I want to give you an example. So let's say we have a quantity that has 80 parts to it, which is the entire. And if we have a portion that's 20, so we know that the ratio of this part to the whole, I'll write it as part over a whole, is 20 over 80. Now, what a percent is, it's to represent the same ratio where instead of the 80 being the whole, we have 100 as the whole. And the question is, what would that portion correspond to? So if we say 20 over 80, we're looking for what this piece needs to be. Let me just call that x out of 100. And if I compute this x, I just multiply both sides by 100. And I can reduce this. So this is 4 goes into 8 twice. That's 5, and I get 25. So what we're saying is 20 parts out of 80 is equivalent to 25 parts out of 100. And another way of saying this is that 20 parts out of a whole of 80 is the same as 25%, because that word really just means 100 per 100. So essentially what we're doing is we're using the same base. The whole is always 100 to write what that amount would correspond to that. And what the idea with percent is, it's easy to compare. Let's say 20 out of 80, how does that compare to 15 out of 90, for example? So when you write anything as a percentage, it's a lot easier to compare as opposed to just looking at 20 out of 80 or 15 out of 90. It's not very clear. So that's the motivation behind the percent. Now, I want to go back to the just dealing with percents as when we write them with the symbol percent. So 20% is really just 20 parts out of 100. We can write in a decimal form, or we can write it as a fraction. So 20 over 100 would be same as 20 over 10. I can reduce it further, so 1/5. So they're all equivalent. You're really saying the same thing. 20% is same as 0.2 is same as 1/5. So you can either use a fractional equivalent or a decimal equivalent, and they're all equivalent. And carrying this on, we say 1% is same as 1 part out of 100 parts. So that would be same as 1 out of 100, or 0.01. 50% would be 50 out of 100, or half, or 0.5. So it's important to know some of the common ones, what they're equivalent to. And if you see 0.3%, that's just 0.3 parts out of 100. And you could write it in decimal form, moving the decimals 2 places back. And I do want to point out not to confuse between 0.1% and 0.1. So if you look at 0.1% is 0.1 over 100, it's 0.001, or 1 over 1,000, same thing. And 0.1 is 1/10, or which is same as 10%. So you'll see that these two aren't the same. So do keep that in mind. That is a common source of confusion, especially when we get into percentages, the quantities which are less than 1. So all of the basic percent problems can be solved with this setup. That's what I want to go over next. So all the basic percent problems, we have part over whole is percent over 100, because that's what we have defined percent to be, that equivalent amount out of a whole of 100. So you will have, there's basically 3 variations of this question, because you have 3 quantities. They'll give you 2 and ask you to find the third, and I'm going to give you an example of all 3 variations, and that's pretty much all the possible ways they could ask this question. So 8 is what percent of 40? So you do have to kind of identify in these questions what's part, what's whole. So here 8 is the part, 40 is the whole. The thing of percent is what's missing. And we can find the percent. I just multiply both sides by 100. and reduce this. 8 goes into 45 times, so 20. So the answer would be 8 is what percent of 40? It's 20% of 40. So that's the first variation. Second is 20% of 60 is equal to. So you can either do it directly, meaning create the fraction 20 over 100, and you're finding that fraction of 60. That's one way, which is 12. Or you can kind of go back to this, and we're really looking for part here. The whole is 60, percent is 20, and then to find part, we just multiply both sides by 60. And again, we reduce this, knock out the zeros. 6 times 2 is 12, with the same answer. And then finally, the third variation is 48%. Actually, I didn't mean that. 48 is 60% of what number? So here, this is the part. Actually, I should just replace it with 48. And the whole is missing, and we're given the percent. So we can cross multiply 60 times whole, and to find the whole, I divide both sides by 60. Reduce this, 6 goes into 48 8 times. I get whole, that's 80. So that's pretty much the three variations they're going to give you in the exam. The ones that I went over, these would be considered the easier medium level problems on the SAT. Now, I do want to comment on the fact that so far we have assumed a context of a part and a whole. We've sort of used that language. But the whole does not have to exceed the part. We can have cases where the part is actually greater than the whole. And in general, we kind of use is the base is the more appropriate use. So here, if I said, 15 is what percent of 5, clearly 15 is greater than 5. But if I had to find that as a percent, 15 over 5, percent over 100, this is 3. You'll find that this is equivalent to 300. So 15 is what percent of 5? 300%. Or in other words, 3 times. They're both the same way of saying that piece of information. Now, they could also ask you 150% of 60 is equal to, so you're saying 150 over 100. That's the fractional equivalent. You multiply by the whole, and then you reduce this. 15 times 6 is 90. So 150% of 60. You can think of this as 150% is 100% plus 50%. 100% of 60 is 60 itself. 50% is half of that, which is 30. So that's 90. Another way to think about it. But and also then finally, the decimal equivalent of 150% is just 1.5. So that's another sort of thing I want you to keep in mind, that the whole can be less than the part. So it's more appropriate to call it just base. But you'll see a lot of people use that terminology. Now, in this portion here, I want to go over the algebraic representation of percentages. When I say algebraic, I mean if they said 20% of x, because you will often see that on the SATs. So you would say just 20 over 100 times x. You can write in decimal form, 0.2x. Same thing, 35% of p. And you'll see that now you can just move the decimal 2 places back, because you're going to only divide it by 100. So you can immediately write that. So this is helpful in many of the problems. Now, there are some problems where the language would be, or they would want you to write the answer in algebraic form. What is x percent of y? So here, when they say x percent, you have to write it as a fraction first. So it's x over 100 times y. This is not equal to just xy. Because if you think with numbers, if I said 20% of 80, this is not just 20 times 80. We know you have to rewrite it as 20 over 100 times 80. So that's a key distinction. And then depending on how they want the final answer, they could leave it in this form. So you do have to glance at the answer choices, or leave it in that form. So you have to be open to that. And the final portion for the percentages are the what we call percent increase, or I should say percent change, percent increase or decrease. And this is typically, you have to use that when a quantity changes from one positive amount to another. So for example, let's say price of an item went up from $64 to $84. And the question is, what was the percent change in the price? So you first find the change. Actually, I want this to be 80 because that gives us nice numbers. So you first find the change, which is $16. And then you find this change as the percent of the initial value. It's always the initial value. So it's basically change over initial value times 100. That is what percent change is. So you find that change 16, find it as a percent of the initial, and to convert that into a percentage, multiply by 100. So this is 8, goes into 16 twice. 8 times 8 is 64. That's 4, and 4 goes into 125 times. So that's a 25% increase. That's what we would say. That when the price of an item goes from $64 to $80, that's a 25% increase. We have the equivalent expression when there's a percent decrease. So let's use those same prices. So it goes from $80 to $64. So again, we find the change, which is $16, and we find that as a percentage of the original. And here, 8 goes into 16 twice, that's 20. So we have a 20% decrease, and it's a decrease because we're looking at the decrease here. So when you're calculating change, you're just looking at the actual, just the magnitude, the difference, and then you recognize that it's decreasing, and so you would say as 20% decrease. And so always remember that the base in that expression, percent change, base here is always the initial number, initial quantity. And that's what gives you the percent change. So, and also I do want to point out that when something doubles, so if any quantity, for example, something goes from 80 to 160, so it doubles, that is equivalent to 100% change. I should say 100% increase. Because here the change is $80, and $80 as a percentage of 80, that's just 100%. So when something doubles, that's equivalent to an increase of 100%. So that completes this lesson on percents.